in this video we're going to use the Gauss-Jordan elimination method to find the inverse of matrix A. So first, the notation: the inverse of matrix A, it's A with the power -1. It has nothing to do with the power, it's just a notation. So this is the inverse of A. Now the definition of the inverse: if you take the A, you multiply it by its inverse, it'll have to give you the identity matrix 1 0 0 0 1 0 0 0 1. Now A is a 3 by 3 matrix. The inverse, if it exists, of course, it's also a 3 by 3 matrix. So what we are doing, what we need to do is to solve this system of equation. Now the system of equation, what we have A here, we have A inverse here, and we have the identity matrix 3 here. Now when we solve system of equations, usually what we do, we ignore the unknown. We know they are there, and then we create an augmented matrix A, and then a vertical bar and I3, and then we start solving. So let's write this: A is -1 2 1 0 1 1, and then 1 -1 -1. Now I3 is the identity matrix 3 by 3. So this is the augmented matrix. What we need to do is to rewrite it in a reduced row echelon form. Now, what does it mean? We need to rewrite all this matrix, the augmented matrix, in this form here. This part of the matrix will have to have the form 1 0 0 0 1 0 0 0 1, which is the identity, the 3 by 3 identity, and then whatever is here, so it's going to be 3 by 3, of course. Whatever is here, this is going to be my inverse of A. Now let's do this, and then at the end we explain why this is the inverse. Okay, good. So when I compare this with this, what do I need? I need 0 here, it's there. I need 0 here. I need 0 here. Also, I need 0 here, and 0 here, and 0 here. Now let's start with the zeros on the vertical line, on the vertical column, the first vertical column. So 0, it's already there. We need the 0 here. How can we do this? We add R3 with R1. So let's call this one R1. This is R2. This is R3. Now R1 will be unchanged. R2 is unchanged. And now R3, we replace it by R3 plus R1. So R1 unchanged, 1 2 1. The vertical bar 1 0 0. R2 is also unchanged. Now R3 plus R1, so we are adding this with this. -1 plus 1 0. 2 plus -1 gives me 1. 1 plus -1 or -1 gives me 0. Here 1 and 0 give me 1. And then 0 0 and then 1. Yeah, 0 0 0 plus 1. Good. So 0 0, we have them. We need the 0 here. We need the 0 here, and this is very simple. We can go, for example, R3 minus R2. So now again we change notation, so this is R1, R2, R3. So if we go this row minus this one minus this one will give me a 0 here. Okay, so R1 unchanged, R2 unchanged, this 1 2 1 1 0 0 0 1 1 0 1 0. So now we need R3, this plus this. Sorry, this R3 minus R2. Remember, we want 0 here. So 1 minus 1 give me 0. So 0 minus 0. 1 minus 1. 0 minus 1. 1 minus 0. 0 minus 1. And 1 minus 0. That gives me a 1 here. So this is R3 minus R2. Good. The next step that we need is to have 0 here and here and here. We start with this, the third column. This is quite simple. We just add R1 plus R3. Why? Because R1, 1 here plus minus 1, that will going to give me 0. So we are adding this with the last row. The first row with the last row, and we will have negative 1, 2, 0, the vertical bar, and then 2 here. Okay, we are adding this term with this, so 1 plus 1, 2, 0 with plus negative 1, and then 0 plus 1 here. Now the next, the second row, so remember these are R1, R2, and R3. Now the second row, R1, we need 0 here, so again we add here. We add R2 plus R3. So now we are adding this with this. 0 plus 0, 1 plus 0, and then 1 plus negative 1, 0, 0 plus 1, 1 plus minus 1, and 0, 1, and that's going to give me 1, 0, 1. Now the third row is unchanged for now. Good. So again we change the notation. Now the last thing we need is 0 here. Now the negative 1 is not a big problem. So we need a 0 here. How do we do this? We need a minus 2. The minus 2 comes from minus 2r. So we are going to put r1 minus 2 r2. Okay, let's change this. Minus 2 r2. Okay, so r1 minus 2 r2. r1 minus 1, 0 there. So minus 1. 2 minus 2 times 1, that's going to give me 0. Here 0 and 0, no change. 0. Now r1, 2 minus twice 2, that's going to be 0. Minus 1, negative 1, minus twice 0. And then 1 minus twice 1, that's going to be a negative 1. R2 now is unchanged. And of course R3 is unchanged for now. Now one last thing and then we are finished. We need the 1 here and the 1 here. This is very simple. We just multiply row 1 by negative 1, row 3 by negative 1. So the last step is row 1 multiplied by minus 1. That's going to be 1, 0, 0, 0 1 1. Yeah, we multiply each term, each element by negative 1. Here no change, and row 3 we multiply it again by negative 1, so that will be 0 0 1, and then negative 1 1, and then negative 1. Now remember, at the beginning we said this is going to be our inverse. Let's see why. Let's call it now B. We started with the equation A inverse is equal to I3. This is known, and this is the unknown. Now this is written now. We have reduced this to I3. We put the unknown, okay? I'm talking about this now here. So this is I3, and then we put back the unknown, and is equal to matrix B. Matrix B, it's this. Let's call it B. Now this simplifies. If you multiply the identity by any matrix of the same size, that will give you A inverse. So A inverse is equal to B, which is equal to the matrix on this side here, 0 1 1, 1 0 1, negative 1 1, negative 1.